don't know me, I'm Alexander, and I just recently finished my PhD in Real Lab in the north of France, and now I'm working in CIRAD in the south. So today I will present to you the Cormas modeling platform and the very cool things that we do with it, and the even more cool things that we plan to do with it. So CIRAD is my research institute, and it is based on, it is an international cooperation center for agricultural and sustainable development research in the tropical and Mediterranean regions. So you can see that it's completely not connected to computer science, and like that in my team, I'm the only computer scientist, and sometimes I feel a bit lonely. Yes, but it's very nice to come here and to be with you. I feel much better now, thank you. So the main reasons of my talk, the main objectives that I have today is first to inform you about the ABM and Cormas platform, then also hopefully to get you excited about the cool things that we do with this platform, and to encourage you to participate in our effort, both by ways of contributing to the platform and by ways of using it, because like that you give us very important feedback. So first, very short introduction to agent-based modeling. Let's look at the birds. So here, if I click this link, hopefully, yes, you see a nice video, and you might even hear the sound. No sound, but the video is nice, you see. There are birds, you see the individual birds are flying, they're super nice in the sky, and now, bam, you see this. What is that? Oh, this is magical. You see, these are super beautiful patterns that are formed by birds when they fly together. And in the past, scientists believed that, in fact, there is one bird that is the main bird, the leader, who decides the direction of the movement, and the leader orchestrates this movement. But now they know that it's not like that. They know that, in fact, every bird, they have their own instincts. They know how to react, how to come closer to another bird, how to not get too far from other birds, to not be eaten by predators. And this movement makes this beautiful patterns. So we call this process the emergence. When, yes, I'm back. This process is called the emergence when, you know, these beautiful certain big patterns emerge from individual collaboration, and nobody programs them, nobody tells how these patterns should happen, but they happen. And this emergence, it gives the two central questions of agent-based modeling. So first, how do individuals act on their own to create these patterns? And second, how do these patterns of behavior then feed back to affect the actions of those individuals? So for that, you see there are very nice applications of this in real world. So these are the examples of where we can apply these same kind of ideas. First, you can see on top, this is the crowd. So you might have heard there were horrible stories in Seoul during Halloween when many people were in the crowd, and there was a stampede and many people died. Same things happen in stadiums. So we need to understand how people move, how the action of one person, the panic of one person influences the panic of another person. If we put many doors in the stadium or few doors in the stadium, is it better, is it worse? The same with traffic, you know, every car, you can see many cars, they're all moving in the same direction. They all have technically the same speed, these are cars, they're fast. But somehow the traffic jam is created because each individual mistake, each individual slowdown of every driver creates this traffic jam. So we need to understand, do we put more traffic lights, do we put less traffic lights? Maybe we make an intersection, maybe like that the traffic jam will dissolve. And the same, for example, to understand the behaviors of animals like these ants, or to understand the financial markets, because financial markets are also individual actions that affect this common patterns. So here's a nice example. You can see how in real world you go to the supermarket and you see a queue, and then you don't know, there are several lines. In one line there's a lot of people with few products. In another line there are few people with a lot of products. And probably each one of us is thinking, we stand in the line like, oh, which one should I choose? Which one will be faster? And then you always choose the wrong one. So, so here is the nice application how we can use also agent-based modeling, because we can write a simple, tiny program that would model this kind of scenario. You will have, you see these small teddy bears, they're standing next to the counter. And like this, you can play with them. You can implement different settings. You can give them a lot or not a lot products, and you see what happens. So basically, that's what agent-based modeling is. It's your little lab that allows you to model certain scenarios, to play with them. When you take real world, you represent it on your computer, you represent it on your screen, and then you can manipulate with it. You can play with it, you can see what happens, you can try different scenarios. So actually, this thing should be moving, and if I do like this, yes, you see they're moving. So ABM is a little bit like that. Now, there are many platforms for agent-based modeling. The most popular right now are Gamma and NetLogo. You can see the one on top there is Gamma, the black one, and this one is NetLogo. But in Sirat, we also develop our own platform, which is Cormas. And Cormas, in fact, was much older than Gamma and NetLogo. I'm not sure about NetLogo, though, because Logo was pretty old. But Cormas was for sure older than Gamma. And it was pretty popular in its time. But as I will show you later, over time its popularity decreased because of certain technical issues. So, but now we're trying to re-implement it in Pharo to turn it again into a new and very sexy ABM platform. So now a very also small introduction to Cormas. So Cormas is a platform for agent-based simulations. It was originally developed in the 90s, so 30 years ago, in Green Research Unit. So that's the same unit where I work right now. And the problem was that it was implemented in VisualWorks, in the old version of VisualWorks, which right now is not, it became proprietary. My institute didn't have money to pay for this proprietary version. And like that for the last maybe 10 years, I'm not really sure, but the development of Cormas were a little stagnated. So the version of VisualWorks Cormas, it works fine. But for example, right now my colleagues, they use the same software that was long time ago. They cannot modify it, they cannot change it. And today it only works on 1 or 2 computers in our lab. All other computers, well. So for that reason, some time ago, very nice people from our community, like Serge, like Tomohiro, like Ernan, they started doing the migration of Cormas from VisualWorks to Pharo. And now one of my important tasks in our institute is to maintain this and to continue this migration to Pharo. So like that, in reality, it's not full migration, because in reality, we have the VisualWorks version and then a completely different Pharo version of Cormas, which is right now not very stable, not very complete, but it is much more modern. It is really, we try to develop it by good practices. So in few words, what Cormas is just a framework for object-oriented modeling. So it provides you some basic classes that you can use to define your own models. For example, you can see there is an abstract model class. There is a class to define a grid. There is a class to define a special entity, an agent, a message. There are more classes, but these are the most important ones. This is basically the core of Cormas. So here you can see an example how you can define a simple simulation when you have a cow and a grass field, and basically the cow is eating grass, and you can have some dynamics how the grass is growing, some dynamics, some logic how the cow is moving from one cell to another. So very simple stuff that you can implement with this kind of framework. Here is another example how you can use a message. So you can have some kind of land, then like slots of land. Then farmers who want to buy or sell land, they might want to use this land to grow some crops, make some money, and they can lease this land. So they can rent land from other farmers. So like this, through sending messages, we can implement some kind of model where farmers are deciding and proposing some kind of amount for land and deciding how to rent it. So what makes Cormas unique compared to those other platforms is that originally it was developed to support the participatory and interactive modeling. So I will tell you about it a little bit later, but the general idea is that Cormas is made from the very beginning to not only for researchers who model something that they don't know, so like they talk to people and then they come home and they model it, but actually to model it together with the people so that we can be in the group, we can model things together, then we can discuss it and we can iterate on that. And this kind of aspect is implemented through 3 very important factors that are provided by Smalltalk. So first is in Cormas there are different points of view on every model. Second is that we can, through our nice tools in Smalltalk, we can inspect and manipulate every specific agent. And third, we can move back in time. So we have a simulation, we can stop it, move back, change it, and then continue. So I will go through each one in a little bit detail. Here you can see an example of a simulation where the red dots, those are cows. The green and yellow, this is grass. So grass is drinking water from the ground, is growing. Then there is sun, which is drying up the grass. And if there is not enough water, the grass becomes yellow. Yellow grass cannot grow anymore. The cows are eating grass. The same green and yellow is the same thing for them. And if cows don't have enough grass to eat, they die. If they have a lot of grass to eat, they reproduce and we have more cows. And then the water is, basically the water disappears because grass is drinking the water, but then time from time there is rain, and rain replenishes the water. So like this, you see there is certain harmonious system that is, and you can observe how it works, you can observe certain patterns. But the important thing here that I want you to see on the slide is that on the left and on the right, it is the same model, same simulation. But on the left, on this side. On this side, you can see the grass and cows, and on that side, you can see the water. So like this, two different people at the same time can observe different, different perspectives of the same simulation. They can discuss about it. They can control different kinds of parameters. The other important aspect is the possibility to inspect and control agents. So for us, it is something we're used to that. You can click on thing, you can inspect it. But for people in other languages and other modeling communities, it's really a shock. I show this to them. I click on an agent, there's inspector, and they're like, oh my God, what is that? And then I write some code, and I can move this agent to another location and make it do something. So they really think this is some kind of superpower. And the third thing that makes us really different and what is very important for us, unfortunately, we still don't support in Pharo version of Cormas. It only exists in VisualWorks version, is the possibility to step back in time. So like I told you, we can play the simulation, then through this interface, we can stop it. We can tell, it remembers all the log of the simulation, and we can tell, okay, I want to move back. I want to change some parameters and then continue. And this is very important when we are together with people. We can discuss some things, we can change some mistakes, we can try to replay different scenarios. So now I will tell you briefly about the super cool research directions that we have around Cormas, because this is something that might give you some interesting ideas of what we can do with it. So yeah, I have some disconnection between the screen and that. So here you can see the process of the conventional modeling, how it happens in a traditional way. So you can see that there is a local stakeholder. This can be some farmers, any people in the society. And there are some policymakers. So those are people like administration, people who make some decision about the life of these farmers. So researchers, they come, they collect data from the stakeholders. They analyze this data, they model it, they process it, they extract some knowledge, and then they give this knowledge to the policymakers so that policymakers can make the decision that will affect the life of the stakeholders. So nowadays, you see in this scenario, the problem is that we only contact stakeholders to collect the data. After we collected the data, we don't talk to them anymore. We come home, it often happens in another country. For example, my colleagues, they work often in indigenous communities in Africa, in Southeast Asia, in South America. They talk to people, they collect information, they come back to France, and then they model the thing that they imagine. But often this model does not represent the reality of the community. Often it is not correct. So like that, today it is very popular, the other approach to modeling, which is participatory modeling. So in that context, researchers, stakeholders, and policymakers, they work together to, they come together in the room, they work together trying to model things, trying to iteratively improve the model, and trying to share the insight in such a way that everyone can express their opinion, share the knowledge, and things like that. Just a second, I must drink. Thank you. So, and this brings the need to develop tools for that. So like I told you already, Cormas is very well suited for this kind of modeling. It is very well suited for communication, for inspection, interaction, and we want to develop these things even more. We want to improve this kind of functionality. We want to develop better tools for this kind of participatory modeling. So there are two important activities that we do in CIRAD, that not me, but my team, my social sciences colleagues. One thing is the role-playing game, the serious gaming, and the second part is agent-based modeling. And these two things, they are very similar, but they have one important difference. So the role-playing games are something that we do without a computer. We design a game. It can be a piece of paper. It can be some really nice and fancy game printed and developed on some very nice tools. But then we bring them to those communities, to those people, and we play together with them. And there's no computer attached. We just play the game, we record the results, and then we analyze them. The pros of this, the advantages, is that it is very accessible, and it is very equal, very personal, very interactive, very democratic. So people can talk to you, people can touch things, they feel they don't need any technical knowledge to participate in this kind of experiment. The disadvantage, of course, is that we don't use computers, so like that we don't have much information from there. We cannot do some very powerful simulations. We cannot do very powerful analysis. It is slow. It is difficult. And when we do this analysis later, it disconnects from people because this analysis is done. First we do the game, then we come home, and then we analyze. So like that, there is this kind of disconnection. Second approach, the agent-based modeling, it is done with the computer. So here in this picture, you can see, and by the way, those pictures are all from CIRAD. These are real simulation, real sessions that we do in the field, that my colleagues do in the field. So here you can see the researcher together with the computer and the people from the local community who look at the screen, and he shows them some simulation of their environment, of their community, and then they discuss the simulation. But as you can see, yes, those people can see the screen, they can discuss, but it creates certain barrier between them because first, it can be inaccessible. They don't know how to use computer the same way as he does. They don't know how to use these tools the same way as he does. And they feel that it is impersonal. They feel that he is another person who came to them, who works with them, but doesn't really understand their needs. So like that, many of my colleagues, they're really against using computers. It's really ideological for them. They say, I don't use computer in my field because for me it's very important to have this personal and human touch. When I come to my participants, I like to talk to them, to understand them, and when I bring computers, they are afraid of me. They don't want to talk to me. So like that, we try to develop also these hybrid approaches where we combine the best of the two worlds. We combine the computer where people can still interact in real world, but computer can support this kind of interaction. And I will show you some examples of some cool projects that we are working on that. Well, you can see already here the picture when this is an actual Cormas simulation that is being projected on the table, and people are playing by moving pieces, and then people still touch pieces, people still move pieces, but they don't need to touch the keyboard, touch the computer. So our general philosophy that we apply to computerization to fight this negative effects of computerization is that one way when people think about computerization, especially my colleagues from social sciences, when I tell them that we need to automate something or add some computers, they think that I'm going to replace people. They think that I'm going to take away their jobs or replace the human communication, and they get super upset. They said, no, we should not do this. But there is another way. So we do not, when we use AI, when we use software, when we use robotics, we do not necessarily need to replace people. We can empower people. We can help people do things in a better, more efficient way without taking away their normal practices. So that's what we want to do. We want to build the kind of tools that would help those people in the communities and researchers share the knowledge, communicate about the knowledge, manipulate certain, test certain theories, test certain hypotheses, discuss them, but still do it in a way that does not oppress them, that does not make them feel that they're not technical enough. So from that perspective, we have three interesting research directions that I am currently trying to promote in my research unit. First is the modeling language. So how can we build a modeling language for Cormas that is accessible for non-programmers? Because right now, I will show it to you later in the next slide, but right now, every modeling platform requires some programming. So we need to, it is not easy to model without programming. The second topic is the tangible interaction. So how can we help stakeholders play with the things on table, touch things, have real physical interaction, and still have support from a computer? And the third topic is collaborative modeling. So how can we use this aspect of different points of view in such a way that different people in the same room can work on the same model, interact on the same model, by controlling different parameters, by seeing different perspectives of that model. So here's the first topic, and as you can see there, it's maybe a bit too small, but this is the script from the Netlog of very popular modeling framework. So the script defines a simple model. It is really a toy example, very simple script. But for me, even for me as a computer scientist, it is not easy to understand the script. It is not easy to work with it. So for my colleagues who are geographers, who are biologists, who are social scientists, they don't know how to program, and for them it is really hard. And I'm not even saying about those local stakeholders who sometimes they don't know how to use computer. So the question is, how can we make some kind of language can we make it easier in some way? Can we make it more accessible? Either through a better kind of programming language or through a low-code, no-code things, or maybe through some user interface. So one approach that we take is the nice object-oriented language, nice object-oriented framework. Because Cormas was originally designed based on Smalltalk because there was a belief that Smalltalk is the easiest language to learn for the beginners. Now, some people can agree or not agree with that, but there are certain benefits of object orientation compared to scripting that makes it more understandable. So as you can see here, you can have a cow, an agent. You can say that the cow can be communicating or located somewhere. So maybe we can make some kind of framework with these classes that you can extend or traits that you can use that would make it more intuitive. Maybe not for the stakeholders, but at least for different researchers. That would make it easier for them to have it like a Lego that you can put together and build your model. Another approach is that in our sessions, we noticed that because we used a lot of, in modeling, we use a lot UML and other kinds of diagrams. And we noticed that many people find it much more easy to work with diagrams than to write code. So can we do some kind of diagram that you draw a UML diagram on the screen and then it generates the code? Like that, people who find it more easy to write code, they could manipulate code. People who find it more easy to work with the diagram, they could draw it and then have the code generated. Now, there are also other approaches. There are approaches to do UI, to do low code, but I don't put them here because right now we didn't explore them yet, and it is not a very trivial thing because still we cannot escape on this level of when we define a model. Next parts will be about manipulating the model. But the moment when we define the model, it is really not easy to escape from coding. It is really not easy to take the coding away. So even if we define UI, some parts of things still need to be coded. And that's why here, these are only two solutions that I show you. And they're still not super trivial. So the second topic is about tangible interaction. This one is very interesting because here again, you can see the real photo from one of our sessions. It is done in some, I think it is Senegal, but I'm not sure. So it is done in a village deep inside the Senegal where they talk to the local communities, they try to understand their practices. And as you can see in this session, it is not necessarily easy to use computers. There might not be access to electricity, to internet. There might not be enough computers in the field. And also what's most important is that computer literacy, because some of those people who are taking part of in these sessions, they might not know how to use computers. Many people know how to use a smartphone, but to use computers, to use Pharo, to use these things, it is not always easy. So to target this problem, we try to think of some tangible interactions. So when you can define this kind of serious game where people can touch things, move them around, and then maybe something will happen in the computer. But you see, we have this hypothesis that when you touch something, it helps you understand it better. It helps you share ideas better. Because instead of seeing it on the screen, we can also do this approach that we, like I showed in one of the pictures, you have the researcher with the screen and everyone is looking. But we believe that when you can touch things, then it's much more effective. So that's why we have this, right now we have one project together with Muhammadu, who is our intern, and he's working on this smart game board. So based on Pharo things and Raspberry Pi, we try to develop this board that can detect the position of pieces. So each piece has the RFID sensor. When you place it on board, it simply finds the location, the XY coordinates, and it transmits it to Pharo. And already with that, we can do a lot because if you have this kind of location, we can use Cormas. So, people are playing on the real board. And in parallel, Cormas image is having the simulation that is, replaying the same thing, calculating the statistics, calculating some charts, displaying it on another screen. So like that, it can guide the simulation. Another approach is very similar, but it is based on computer vision. So instead of using instead of putting the figures on the table and detecting from the beneath where is the location, we can put a camera above and try to capture the location of each piece. So this is another project. We don't have any student working on that yet, but we are now collecting a lot of data because we bought the small camera that we attach like that, and every time my colleagues, they do some kind of gaming session, we record the video, we split it into images, and like that we now are starting to build a nice data set for this kind of experiments. So here also you can see in this picture the experiment that was done by our team because they have developed this projector. It's the horizontal projector that projects the Cormas image, the Cormas visualization on the table. But the important thing here is that it only does the output. So people play the figures, it outputs the state of the screen on the table, but then the input must be done manually by a researcher. So there's always some researcher who's like, tick, 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 tick. And we want to change it, so that's why through this computer vision, or maybe through the Internet of Things solution that Mohammed is developing, we can also provide the input. So that would be very, very powerful. And the third solution, this is something we didn't even consider for now, but it is something that we would really like to do in the future. It's also the combination of modeling and virtual reality. So in our community, we have Ronnie, who works on the wooden engine, who does super nice things with virtual reality in Pharo. And it would be very interesting to see what kind of things we can do with that. So when we have, for example, a Cormas simulation, and then VR glasses, when many people maybe can interact with something in 3 dimensions. The third topic, the final topic, is the question of collaborative modeling. And here you can see the problem is that in our sessions, I show you there are stakeholders, policymakers, and stakeholders are often of different types. So you have, for example, farmers, pastoralists, fishermen, and policymaker, and they're all in some kind of conflict. And my colleagues who are anthropologists or ecologists, they try to resolve this conflict. They try to understand, for example, why abusive fishing practices that take too much fish from the river is making problems for farmers. But each one of them, they have their own perspective, their own point of view. They understand only their own resources, their own application. And the question is, how can we help them collaborate? How can we use this point of view thing that we have to help them really maybe use different devices, maybe participate better? And here you can see the solution that we have in mind is to have one model that can be distributed among different devices, where, for example, people can use their phone or can use their computer to see different version of the model, different point of view on the model, and maybe control different sets of parameters. Like that, a farmer can control the growth of crops and say, okay, this is enough, this is not enough, this is the problem that they have, and fishermen can observe the fish, and policymaker can calculate the money and see how the money is growing. So, and a very important thing to understand here is that it is not done, so we are not trying to really model the real world and to approach it to the realistic scenario. We are trying to engage them in communication. So when, for example, they can control these parameters, then they start talking. They start saying, you make this problem for me, why did you do this to me? And it is that we are targeting, is that we want to receive from them. So thank you very much for your attention, and I would be very happy to answer your questions. Yes?
So in what region does these experiments or these communities looks like Africa, or where is it where you do these experiments?
Yes. So thank you for the question. Do I need to repeat it, or it was recorded on the... Repeat, okay. Yes. So the question was, in which regions are those experiments performed, in which communities, and so on. So our team is based in many different locations. I could show you the map, but I'm afraid to lose it somewhere. Basically, the main locations for our research unit is Senegal, Madagascar, Bolivia, Brazil, and Southeast Asia, so Cambodia, locations like that. So this is our team. Other teams work in different regions, but generally it's the regions of the Global South. So it's everything that is south from Mediterranean and South America, Southeast Asia, maybe a little bit Middle East, but I'm not really sure about that. So like that. Personally, for example, I'm technically, like formally attached to Senegal and to South America. But in reality, as a computer scientist, I don't have real attachment because, you know, anthropologists, they need to collect some data, they need to talk to communities. But for me, so like that, I'm between all these countries. Yes, please?
Yeah, regarding the interaction between these three parts, the communities, the policymakers, and the researchers, at least in our case that we were also with communities, with indigenous ones and local communities, there is this issue on, let's say, intellectual property in a way, because the researchers want to do papers, but that doesn't resonate with the community. The communities don't want to read papers about themselves. They want to use the artifacts that were created with the researchers for the policymakers, this kind of more, let's say, dialogical artifact, something that you can use to dialogue inside the community and also with the policymakers. Which are the ways that these artifacts circulate, and which are the licenses for that? Because that's the part that, for me, at least in my experience, is more important for the community,
Yes.
not the paper. So how do you build commons with the communities?
I will try to summarize this question and repeat it for the audience. So thank you very much. So the question was that when we work with these communities, we produce certain kind of intellectual property, we produce certain kind of artifacts, and communities have their interest to make use of those artifacts. They don't want that we just take them and make research, publish papers, but what is the way that we license them, what is the way that we make sure that the communities can also benefit from those artifacts. Is this correct?
Yeah,
Yes.
correct.
Thank you very much. So I'm not really a person to answer that question, because this is really a question for my colleagues in social sciences who deal with these problems. I can try to answer it the best I can from my very humble understanding of the good work that they do. So first, the question of commons, it is really central question of our research unit. It is really most of their publications are around commons. Personally, I don't really understand what it is. I have like a general understanding, but it is not super easy for me to perceive this idea of commons. But if I understand it well, the question is that in the environment, in the ecosystem, there are certain resources that are shared by the by the nature, by the animals in the nature, by the people, by the entire community. I'm not sure if it's the same thing, but yes. So they ask this question a lot, and they put so much work to try to understand how to feed back these results. So they try to, for example, valorize these results together with the research communities. They do a lot of workshops in place. They do a lot of, for example, last week they gave me some chocolate that they made in Madagascar, where it was written that it was funded by some Sirat project. So basically they work on some project, they make like eco-friendly chocolate, then they distribute it in France, and all the money comes back to the community. So there are some very interesting, like I don't really know how to explain this, how to answer this, because my answer will be bad. But what I can see by working in this team for 8 months, I see that this question is really central for them. And I sometimes feel that they put much more energy specifically in that question, in the question of, how to do this in the normal, equal way, how to do this in a way that we don't take away these resources, we don't take away these findings, and we use them for ourselves, how to make sure that these findings can still benefit the communities. And so like that. But another thing that I wanted to emphasize is that it's also the benefit of the participatory modeling, because this modeling, this approach, it is iterative. So for example, we don't just come to them, talk to them, take data, leave, and then do our science, do our research analysis. We talk to them, we come back, we make a model. We come back, we talk to them again. Is this model good or not? We come back, again, we do analysis. Come back again, talk to them. So it's like this, iteratively, we try to involve them in the process, and we try to make sure that they're not just, like I said, they're the actors of this transformation. So they don't just provide data for us, they also participate in collecting this data, understanding these things, understanding the results, and then maybe taking action on these results. I hope this answers the question, because I really cannot answer it better than that. Any other questions? Yes?
In your experience using the simulation, did you find a predictable thing that happened in the simulation and that you will, after that, foresee in the real interaction between the people?
Okay, thank you for the question. So the question was, in my experience with simulations,
With this project, I mean.
Yes. Did they ever encounter
Like, for example, you will see interaction
Yes.
inside the simulation
Yes.
with agents. And then after that, you will see them on the real world. Completely
Yes.
separate.
Thank you very much. So the question was if I saw in the simulation some interactions, some patterns that I later observed in the real world. Okay, easy, no. I will explain why. Normally it happens all the time, yes, always, and that's the goal, we don't try to really reproduce the world, but we try to make something that resembles the world. So, and these patterns that we see, it also helps us understand the world better. So for example, this emergence things, with birds, and I want to show you some nice thing. You see here, for example, I implemented this model. It was just a toy model. But if I play it, you will see that the grass becomes yellow, then it all disappears, then it becomes green again, then it all disappears. So then it becomes yellow again, then it disappears. So there is this kind of fluctuation. You know, there is this kind of seasons. I didn't program these seasons. I didn't say there must be seasons. But just from the fact that I said there is grass, they eat it, the seasons appear. So this thing emerges. So this is the kind of thing I observed. This always happens, they observe it. But why I said no? Because in fact, I am not a modeler. I am a developer, a computer scientist. I work on the Cormas platform, but I never really use this platform for modeling. It is my colleagues who use it. And also I'm very new in this field. I'm super newbie in modeling. So like that, I never personally observed how they do it, but I know that they do cool things with that. I'm more on the side of the, computer vision, IoT, robotics, these things. But unfortunately, this year, my colleague, because we have also some colleagues who often come to ESUG from CIRAD. So for example, Pierre Baumel or Etienne Delay, so they're actually modelers. They can give you very good answers. They can, and in fact, maybe Tomohiro can give good answers because, no. But yes, so maybe next year, if you're lucky, we will come with the colleagues and they will give you a much better example of how these things are used. Yeah. Yes. Any other questions? Okay, if not, we can go have coffee. Yeah. And yes.